everybody, it's shipment day today at Big T's Chop Shop. We have a new machine coming in, but this one is something super special that very few other people have their hands on right now. So we're extremely lucky to be able to feature this, and hoping that you'll enjoy watching the unboxing of our brand new Tormach robot arm manipulator. So stay tuned, let's take this thing apart and see what we got. Alright, so inside the crate with this bad boy, we got a series of numbered boxes which we'll have to figure out. We've got a Versa Grip gripper kit in with the robot as well, so I'm expecting these are probably components of that. Pretty exciting, it's kind of like Christmas. Let's see what we got here. Okay, a bunch of labeled parts. Made the trip up to Canada here, okay. And there we have it. So you can see down here the ZA6 label. Everything else is tightly packed up, so we are going to get this cut open and moved into the shop here shortly, and we'll see what we got. So there it is in full effect. A Tormach ZA6 manipulator and the associated PathPilot controllers and control box. Alright, so next steps. We've got the robot up on the table here. It was a bit of a heavy lift. I mean, you definitely want help or a spotter to help you get it up on the table, around 130 pounds, but I was able to get it up here, not too big a deal. Next step in the process is basically to make sure that it's firmly affixed to the table. So we've got a heavy duty U-line packing table here, and we're gonna put this metal plate down as well. Just a 1/4 inch piece of aluminum to help spread the load a little bit onto the surface of the table. Each of the corners of the robot's getting bolted down with a bolt that goes right through the table, and then a fender washer on either side to make sure that it's stable. I'm assuming that the robot, you know, as it moves and the momentum and stuff like that is, you know, it's fairly heavy and it can move fairly quickly, so it's going to have some momentum. So we really want to make sure that it's locked onto the table and that we're, you know, have a nice stable surface for it to work on. So that's sort of the next step. I'm going to get this drilled up and mounted on the table. so in terms of our work area, I think the most important thing is that, you know, we may have to move these things around and figure out how it all works, but I'm imagining having this desk and being able to sort of sit here and operate. Definitely a big thing though is to have access to the control panel and the e-stop in particular. So I believe having the e-stop right here should do the trick. We'll have to experiment with this. I mean, the control box is close enough that the cables reach, and that connection part looks fine. The power I can run underneath the table to the box, so I think everything is good there. And then convenient access to the e-stop in case things should go awry. One of the coolest things about the ZA6 and its control system is that it's based on PathPilot, which is the standard controller that Tormach uses for all their machines. So I have it on my 1100, I have it on my Slant Pro lathe, and now it's going to control the robot. And it's one of my favorite parts of the Tormach ecosystem, so I'm really excited that this is what they've chosen to control the robot with as well. The controller is PC based, has a monitor, mouse, keyboard, pretty familiar. So we're gonna get that set up right now and hooked up. There's an Ethernet connection that goes to the control for the robot, and that should basically be the last step to get this thing powered up and ready to roll. So let's give it a shot. Okay, so this is the moment we've all been waiting for. Everything is connected. We've got the controller powered up. We've got power to the robot. I think we're ready to give this a shot and see what happens. So bear with me here. I don't know exactly how this is gonna go, but we're gonna fire up the robot and give it a shot. So first step here is to get PathPilot opened up. So it's a little bit different than the interface to, say, a Tormach mill or a lathe, because you know, this is a computer. This is a robot. We're programming it. It's not running G-code. It's running Python. So a little bit more of a desktop environment to start. I don't know if that's how it will be when the final release comes out, but for the beta, that's what we've got. So we're going to fire up PathPilot. There is a simulator that you can use to kind of practice and to work offline. We just want to see the robot go, so that's what we're going to launch. So here we go, fire up PathPilot, and we'll have a look around. Okay, so first thing that's a bit different in PathPilot from what we're used to seeing is that we've got a robot on screen. Obviously, normally on a mill or a lathe, you can see the axes and positions and stuff. In this case, there's a visualization. Looks like they're running RViz, which is the ROS visualizer. So we're gonna fire things up here. So we have to turn the power up on our box, much like all the other Tormach machines. You hit the reset button and, you know, click, and the robot comes to life. So I think the first thing is we're just going to try some basic movement and see how this works. So going over to the jog tab. Now this interface shows obviously there's a few different ways you can move the robot around. There's direct joint controls, there's Cartesian movements, and then you're also able, I believe, to drag and drop or to pull the sort of end effector of the inverse kinematics rig around inside of the visualizer as well to move the position. So I'm going to start just by understanding what all the joints are. So basically, if I highlight joint 1 here, I'm going to zoom in just a little bit so that we can see the robot arm a bit better. Let me pull this down. Okay. So there's our visualizer. Joint 1 rotates the base. So pretty straightforward there. Joint 2 is the kind of lower part of the arm, so we're gonna lift our arm up a bit. Joint 3, similar joint but on the upper part of the arm. Joint 4 looks like it controls the sort of twist at the, I don't know if you'd call that the elbow or the wrist, but controls the twist joint on the arm there. Joint 5 looks like it's, I'm gonna call that the wrist. I don't know if these are the right technical terms, but in terms of how I'm interpreting it, that would be the wrist. Joint 6 looks to be the actual tool rotations. You might not be able to see this on the camera, but I'm rotating the red ring on the bottom of the robot. So that's normally where a tool, either a gripper or whatever, would be mounted. I don't have anything on my robot right now, so it's just the bare gripper. So I mean, that's sort of all 6 of the degrees of freedom, direct control. Okay, so next is we have these Cartesian controls over here as well. So it's fairly obvious to me sort of what the X, Y, and Z might do. Let's just make sure that's correct. So I'm moving in X there. Moving in Y. And you can see how the basically the kinematics is keeping the robot tool in exactly the right orientation. So basically the tool mount stays fixed as I'm moving X and Y there. Now I've got a little bit of jitter. I think it's the rigidity of my table, which might be something I'm gonna have to work on. But for now, it's not super critical. While we're figuring this out, might need a little bit of extra bracing on the table. So that was our X and Y. Let's take a look at Z. Again, up and down. Everything is staying exactly sort of parallel as far as the tool orientation is concerned. So that's pretty cool, that makes sense. So I'm jogging around in Cartesians. Okay, so now I also have these 3 rotational controls, and I'm not 100% familiar with what they are. I mean, it's fairly intuitive here. Like when I click in the visualizer, I can see the sort of degree of freedom that this controls. So A is kind of bending that wrist in and out, but you can visualize that the tool plane there is what I'm actually manipulating. So it looks like I'm manipulating the angle of the tool plane. I'm sure we're going to learn more about this later. B, again, I'm manipulating the pitch of that tool plane now, if that's what you want to call it. So basically, you know, it looks like A is sort of the rotation on the one axis there, if you want to call it X. B looks like it's the perpendicular one, so I would call that Y in this case, I guess. Let's take a look at C. C's controlling the rotation. That might be a little bit subtle to see on the camera, but pretty straightforward. So again, so that's sort of our kind of Cartesian move system. Now, I can imagine that setting waypoints and setting positions using that sort of system, you know, seems straightforward enough, but there's other ways to move the robot. So we're gonna have a look at those next. Okay, so the other way that we have to move the robot is in the visualizer here itself. So if I rotate around, there are these markers on the end effector that I can grab, and I can change the position of the robot. And when I do that, this hold to move button becomes active. So if I grab that and hold down, then the robot's gonna move to that position that I basically dragged out in the visualization. So that's the other way to kind of create motions here, which is really kind of cool. Definitely get a sense for how quickly it can move when you're running in that mode too. So PathPilot does have these controls for basically restricting the feed rate and the maximum velocity of the robot. That's probably something that will come into play in practice, especially when you're programming and you're testing out some of these moves. I would think you probably don't want to run at full speed. So, okay, so those are the basics. For our final segment here of this video, what we're gonna do is we're gonna try to program a basic waypoint program. So I don't have a gripper or anything fancy on the robot right now. What I do have is a cardboard cutout on the table with a little piece of double-sided tape on the back of it. I'm gonna see if I can write a waypoint program that'll let the robot come in, pick up the cardboard cutout by sticking onto it, and then come around and show it to the camera. Not super exciting, but let's see if we can pull it off. All right, so I think I'm just gonna use the current pose as our starting waypoint. So we're gonna say new waypoint from our current position. Great. And we're gonna move the robot over. I'm gonna use the Cartesian move here. We're gonna move the robot over and try to get it above our position. So I think that's probably pretty close. So we're gonna set a waypoint there. Then we're gonna come down in the Z-axis, and we may have to fine tune the position here a little bit, that's fine. We're gonna come down, that tube is sticking out. Maybe I'll just tuck that away for now so it doesn't get in the way. Just fold it over. That normally holds accessories and conduit. It's conduit for you know, either pneumatics or add-ons. We're gonna move over our piece of tape there. I'm gonna set this as a waypoint. Then we're gonna come down in Z. We might have to fine tune our position a little bit here as we go. Come down in Z. Let's adjust the pitch of that angle a little bit on the wrist, so we get a nice flat contact point. Same thing. Move out a little bit. Bear with me, I'm not the greatest with these controls yet. Okay. And then we're gonna push Z down onto the tape. Now we can control our step sizes here, I think, to make it a little bit less prone. So we'll set a waypoint there where we stick onto the tape. Then we're gonna move our Z-axis up. I'll move to a bigger step again here. Move it up. Actually, we'll go back to continuous. Move it up so we've picked up our part now. We'll set that as a waypoint. Then we want to rotate our base. Rotate our upper joint. And I think we could probably use joint 4 to rotate that wrist. Joint 5. And joint 6, because, well, we don't want to go thumbs down. We want to go thumbs up, because that's awesome. Okay, thumbs up. Thumbs up, and then a little bit more on, sorry, joint 4 I want. A little more joint 4. Oh, wrong way, there we go. Thumbs up. Okay, and then we're gonna set that as a waypoint. And then I think we should kind of go back to a bit of an intermediary there at the end. So, or maybe we just rotate the base away. Call that our final waypoint. Awesome. Okay, so we have a program, or we have our waypoints anyway. our conversational mode is going to allow us to add these to a program. So we're going to turn down our feed rate here a little bit, just so this isn't getting too rowdy. And so we can add this to our program, add this to our program, add this to our program. You can see I'm basically just taking all my waypoints, putting them into the program. There we go. So then I believe we should be able to add an exit to our program at that point, and the program should stop. And I think we're good to go. So we're going to save our program here as thumbs up. And when we go to our main, we can see what's going on here. It's pretty straightforward. I mean, we've created a little Python program for ourselves here through the conversational mode, which is basically define that series of waypoints that I put in the table, and then we move through that series of points. So we're going to slow everything right down here, set a pretty conservative move rate, and I'm going to reset the thumbs up, and we're going to run our program and see what happens. Okay, so we've got fresh sticky tape on our cardboard cutout. We've got our program loaded. We've turned down our speeds so that we can stop this if everything goes horribly wrong, and we're ready to run our program, our very first program here on the ZA6. So let's see what happens. So you can see it moving through the waypoints that we set up. See if I got the tape in the right spot. Touch down, pick up our cardboard cutout thumb, and there we have it. The thumbs up. All right, so there we go. So successful execution of the first program. It was actually pretty straightforward. So I mean, you can imagine that the complexity of this gets quite a bit more involved as we start to add different elements and, you know, locations, grippers, things that need to be picked up. But the core principles and the way the program in Python is related to sort of the motions and how you set the waypoints and stuff, it seems straightforward enough. Like, I think we should be able to do some pretty interesting things with this. So thanks a lot for watching. Definitely stay tuned. We're gonna move on to sort of obviously more complicated working operations, and put a robot, you know, put the gripper on the end of the robot, end effectors, and see if we can get it doing something a little bit more useful. But for now, very exciting. It was pretty straightforward to get everything set up. The robot seems to be working great, and we're ready to roll. So thanks for watching. Take care. We'll see you again next time.